Okay, so we just got through some pretty intense work in 9.3. We're going to have a little bit of a less intensity here to give ourselves a bit of a break, and let's do a few more exercises. So here's a totally different type of style of exercise. It just says simplify 6 sine pi over 10 times cosine pi over 10. And I'm like, well, okay, what can I do with that? We gotta get used to referring to our identities and thinking if they can help us with a certain kind of a problem. And with this problem, when I see that I'm multiplying sine of an angle times cosine of an angle, it does kind of make me think of this sine 2 theta identity that has the sine theta times cosine theta in it only, right? Now it also has that factor of 2, so it's only going to be useful if we can figure out a way to rewrite this with a 2 times, and it's actually not too hard to see that we can just say that's 3 times 2 sine of pi over 10 times cosine of pi over 10. So this should kind of make us think 2 sine theta cosine theta is what that portion looks like. And our one identity tells us that's equal to sine of 2 theta, our double angle identity for sine. So that's this portion is equal to sine 2 theta. We still have the 3 times in front of it, right? So we have 3 times sine of 2 times, now it's not 2 theta because theta is pi over 10, it's 2 times pi over 10. So I have 3 sine of 2 pi over 10 is just pi over 5 when I reduce that, right? So 3 sine pi over 5, and that's our simplification. We were able to simplify by applying the double angle identity for sine. Here's another similar kind of situation where we have a cosine squared minus sine squared. And once you start working with these identities, just certain not alarm bells, but just signals go off. When you see cosine squared minus sine squared, that makes me think of the cosine 2 theta identity. And so this looks like cosine squared theta minus sine squared theta, which is cosine of 2 times an angle. That's that double angle identity for cosine. Now we don't have a theta here, we have our 5x, so I gotta think, okay, this is equal to cosine of 2 times 5x, because the 5x is my theta, or cosine of 10x. Wow, I even gave myself way too much space for that one, right? Okay, now let's do another. So I'm going to move right on to another example. And here I have, let's see what's going on. Let's hope it's as easygoing as those two. Given that cosine 2 theta is 5/13, find all 6 trigonometric functions of theta. Now this should feel, it seems a little bit like those ones we were doing, like I want to flip to an earlier video, this type of thing. But the weird thing is, and there were problems where we were trying to find the double angle trig function values. Here we're given the double angle values, and we want to work our way backwards. So you can actually just plug in to these guys. I'm actually going to invoke these reduction formulas that we talked about in an earlier video. Now really all I'm using is the cosine 2 theta identity in this form with sine squared, where we solve for sine squared. And I'm going to recopy that. So I'm going to say use the reduction formulas. So we have sine squared theta equals 1 minus cosine of 2 theta all over 2. I'm copying it from my reduction formula sheet. And as I flip all my different identity sheets here, it is related to cosine 2 theta, where if we can get this formula from this one of these lines of the cosine 2 theta identity if we just solve for sine squared, isolate sine squared. And now to get sine squared, I just plug in, because I got 1 minus cosine 2 theta, that's 5/13 over 2. Let's see, 1 minus 5/13, so that's 13/13 minus 5/13 is going to be 8/13 over 2. That's 8/26 or 4/13 is my value of sine squared theta. So sine theta is plus or minus the square root of that. And we have quadrant information here again, given right up here at the beginning of the problem. That inequality about theta being between pi over 2 and pi, that's telling us we're in quadrant 2. So since we're in quadrant 2, we know that sine theta has to be positive, right? Because y is positive, quadrant 2. So this is going to be positive 2 over the square root of 13. There's one of our 6 trig functions. We got sine of theta. Now, that was, sine squared was one of my dotted line formulas. I had another one of those for cosine squared, which is 1 plus cosine 2 theta over 2. Isn't it funny how similar these two are? So again, I'm just copying it from my reduction formula sheet. If I didn't remember it or have it handy, I could just take the cosine 2 theta identity with cosine squared involved and isolate cosine squared. That's really where this comes from. And I'm going to do the same calculation now, but with 1 plus 5/13 over 2. So that's going to be, is that 13 plus 5 is 18/13 over 2, which is 18/26 or 9/13. And so cosine, let's say cosine theta, we're ready for cosine theta here, is going to be plus or minus the square root of 9/13. Let's see, cosine theta is going to be negative, right? Because we're in quadrant 2. So as far as cosine's concerned, that tells us to take a negative 3 over the square root of 13. Now I got my cosine value from the reduction formula. Okay. Now, once I get sine and cosine, everything else just falls out at this point, because to get the other 4 trig function values, I can express them all in terms of sine and cosine. So tangent theta is going to be sine over cosine, which is 2 over the square root of 13 over negative 3 over the square root of 13. And when you work that out, that square root cancels out. I have just negative 2/3. Cotangent theta is cosine over sine, or you could just remember that cotangent is the reciprocal of tangent. So that's going to be negative 3 over 2. Can verify that. And what do we also need secant and cosecant. Secant theta is 1 over cosine theta. or 1 over negative 3 over the square root of 13. Just, again, that's just the reciprocal of cosine. So I'm going to have negative square root of 13 over 3. And cosecant theta, which is 1 over sine theta, is 1 over 2 over the square root of 13. And when you go ahead and simplify that, you'll have square root of 13 over 2. And we got it. We got all 6 trig function values. And let me see if we can do a back out shot of this one to get the whole thing. Almost got it. All right. All right, there we are. There's the whole problem, and I'm going to stop, and I think we're going to finish up this section in one more video segment.